front here. Okay.
Thanks. You had to click it twice.
Okay, so this one, the variation of the formula Ohm's law is the resistance equals voltage divided by the current. Right? And this example, the voltage source on the wall equals 115. And this is in series with the light bulb, which is the load, and the resistance is what we are looking for. And the current equals 0.87, which is measured. So what is the hot resistance here? We just use this formula R, the resistance equals the voltage divided by the current. So that equals 115 divided by 0.87. Everything is okay because all the units are already standard. V is voltage is V, current is A. So 115 divided by 0.87, the result equals 132. You just put the unit ohms because this is also the standard unit. Any questions on that? That's very easy, right? Yes. So Ohm's law, we have three variations. We can calculate the voltage, we can calculate the current, we can calculate the resistance if we know the other tools. Okay, now this one is the sometimes you are going to go to the lab, you are going to maybe you need to draw this plot, right? So this one is for a particular resistor, and you measure the current flowing through it, and you also measure the voltage across it. Right? So, for example, you apply voltage, right? The voltage equals 2. Then you measure the current, and the current looks like a 3 something. Then you do the second measurement, the voltage you change to 4, and you measure the current, it looks like a 7 something. And you do all this 1, 2, 3, 4, 5 measurements. And you put all this dot on this diagram. Right? Then you draw a best fit line here. And what we want is from this line, split line, we want to know what is the conductance and the resistance of this resistor. You can see these dots are not really on the split line, right? Because when you take the measurement, you have some errors. That's for sure, right? So we are going to use this fitted line to measure, to calculate the voltage, to calculate the resistance and the conductance. Right? So we assume this line is correct. So how to measure this resistance? Ohm's law tells us the resistance equals the voltage divided by the current. Right? So what we do is we take 2 points on the split line. Right? The 2 points is better to be easily read. Okay, so for example, the first one, okay, I would like to this origin. Right? So we can see the voltage equals 0, the current equals 0. So that's why is the easiest one. The next one, okay, so which one is right on the line? This one not, this one looks good, this one definitely no, this one okay, so maybe, okay, I will use this one. Right? Usually if for same conditions, you are going to use the further one. The further away, the better accuracy. Right? So I'm going to use this point. I'm going to use this point. Right? So I will read this voltage here equals 0, current equals 0. This one, the voltage equals 10, the current equals like maybe this is 0.15, so 14.8 maybe. Right? The resistance will be equals to the voltage change divided by the current change. Right? So from here to here, the change of voltage equals 14.8 minus 0, which is 14.8. Right? And the current, what I said is the current, right? The current change here. See, this is the current. The voltage change from this point to this point is from 0 to 10. So that means V equals 10. Right? So the resistance will be equals 10 divided by 14.8 and times 10 to the negative 3. Right? So that is the resistance. The conductance is the reciprocal of the resistance. So we just use this one here. This change in the I-axis divided by the change on the voltage axis. So that will be 14.8 divided by 14.8 times 10 to the negative 3, then divided by 10. Right? So the result, so here the conductance equals 14.8 here minus 0, which equals here, and divided by 10, which is this one, minus 0, which is on this line here. Right? So the result equals 1.48 millisiemens. So that is the conductance. The resistance will be equals just 1 over this one. Or you can use just this one divided by this one. So they are reciprocal. Right? So the reciprocal of the conductance is the resistance. So equals 1 over G. Right? Equals 10 divided by 14.8 times 10 to the negative 3. Which equals 676 ohms. Any questions? So in the lab, if I give you a resistor, right? You cannot read, you cannot measure the resistance. You can use this way to measure it. Right? You measure the current voltage curve to calculate the resistance and also the conductance. Question? Okay. This one, the graph of current versus voltage. Right? So for fixed resistance, we know the voltage equals I times R. If your R is constant, then the voltage will change linearly with the current, or the current will change linearly with the voltage. Okay? So the larger the voltage, the larger the current. Or the larger the current, the larger the voltage, because the resistance here is constant. So it will be a straight line like this. Question on that? It's good? That is just V equals V equals R times R. Right? And we assume this one is constant. For example, equals 10 ohms. So then the voltage equals just 10 times R. What this line is? This line is a straight line, right?
Yeah.
This is the slope, this is the horizontal, or in this case, this is the vertical, no matter what. So this one can be equals 0.1 times V. So this is the slope. This is the horizontal, this is the vertical. Right? When you calculate the resistance, for example here, for this example you can easily calculate. The resistance equals the voltage divided by the current. So the voltage, again, we pick this point, and this point may be at 25, 26, 27. So this one equals 27. Right? So 27 divided by 10, so equals 2.7. Why it is K? Because this is a V, this one is a milli, so negative 3 on the bottom. So it will be positive 10 to the positive 3 on the top, so that's why it's K. Make sense?
Yeah.
Okay. What is the conductance? That is 1 over this number is the conductance, right? So 1 over 2,700 equals 0.37 millisiemens. If we keep the source, the voltage, your battery is constant. Right? You connect to different resistors, you measure the current. You use the same battery. And you connect to different resistance. And you change the resistance and you measure the current. So let's see what the curve look like. In this case, for example, if your voltage equals 10, let me see. Okay. What is the curve for a 3 volt source? That means the voltage equals 3. So here, this one equals 3. And we change this one will change. So 3 equals I times R. And we change this one will also change. So this up, this will go down. This go down, this one will go up. What we draw here is the resistance and the current. The resistance and the current. So what this curve look like? So you can see this one, the multiply equals 3. So if R equals 1, then R must be equals 3. If this one equals 1, this one will be equals 3. So let's see the point. Right? So those are the points. The first time we do this, the resistance equals 3, then you can see the current will be equal to 1 because they multiply together equals 3 from here. So that's the first point. Next point is this one equals 2.5, then this one will be equals to 1.2. Right? So that is this point. Then 2 here is here. So if the resistance equals 1.5, then the current 1.5 here, here the current must be equals to 2. So make the product still equals 3. So that will be 2 here. Right? So this is 2. And you do all these points, and you draw the curve. The curve looks like this. And this is called a pep. Right? So this curve looks like this. Now we have an example here. Application of Ohm's law. The resistor is green, blue, brown, and gold. What should be the ammeter read? So look at, you can see this. This is the current source. This is the voltage source. The voltage source provides the positive connect to here. This one is a breadboard. You are going to use this in the class later time. Okay. Last time, yesterday, I don't think you discussed this. Later time you will. So this board, this line are connected. You think under this hose there's only one straight line. So these are connected, and these are connected. Right? This one you need to memorize this. And all these are connected. These are connected. This connected, and these are connected. This connected. And all these are connected on this side. This connected on this side. Does it make sense? You're going to know the details later time, but now you only need to know this positive connect to here to this. That means this is also connect to here, right? Because this is a straight line. And then to the current positive, then to the negative, use this ammeter to measure the current. And this one connect to here, and this point is the same as this point because these 5 holes are connected. So this one here is connected to this. Then pass through this, connect to this point. Now this point and this are the same because these 5 also connected. Right? So this one here goes back to here, and this one is the same as this one because all these horizontals, usually we call this ground, we call this source. So all these holes are connected. So this one all connected to here, then goes back to the negative. So we have closure. Does it make sense? Yes. So later time in the lab, you are going to play with this one. Even in the senior project, you try your circuit. You have some invention. You want to invent something. As the first step is you use this breadboard to make this circuit. If it works, then you print that's the beautiful PCB board. But step 1, you use this one. Okay, now we know this resistance, right?
Yes.
What is it? It is green, blue, brown, and gold. Gold, this means plus minus 5%. This one green, what is green? 5, right?
5.
This one? 6. This one? 1. So this is 5, 6, 0. So 560. And this one is only the tolerance. What is this number here? That's what we are looking for. Alright, this is 15. Use Ohm's law. 15 divided by 560. That is the number supposed to be here. Right? Maybe some variations. The reason is because there's a 5% up and down. Right? So it's not exactly 560. So what's the result? 15 over 560 to 26.8 meter. So you said 0.0267 something. That's correct.
Yeah.
Okay, any questions about the application of Ohm's law? Actually, you can play with 3 types, right? Voltage equals current times resistance. Resistance equals voltage divided by current. Current equals voltage divided by resistance. All these 3 are from the same thing. Okay. Any questions? It's good?
Yes.
Now we are going to discuss the power. You have taken physics before, right?
No.
No? Never?
No.
Okay, somebody yes. Can you calculate the power, not electric power, any, for example, mechanical power? For example, I move this thing, right? Here, I apply a force on this, then I move this way, right? So suppose the force equals like 10 Newton, right? Not pound, right? 10 Newton, the standard unit. And move the distance equals, for example, 1 meter. How much work I need to do to this object? I know the force, I know the distance. Anyone knows how to calculate the work?
It's F over D, right?
Yes, the work F times D, right? The force times the distance. Okay. Like this one, you move the box. From the left to the right, so that's animation. Like this. See, you move this. You need to apply a force, and you move this with some by some distance. So the work needs to be done to this item is the force in Newton multiplied by the distance from here all the way to here, and in meters. So F times distance gives us the work. If you use newtons as the unit for the force, if you use the meters for the distance, then you get the work, F times D. What is the unit for the work? Joules, right? So if you use the standard unit, you don't need to care about the unit. So you just know that it is joules. After your calculation, you just put the J at the end. Everything is perfect. Because it is the force times the distance, so you may say, oh, that equals Newton times meter. Yes, Newton times meter is equal to joules. Right? This is the same. Any questions on this? Okay. How large is 1 joule? 1 joule equals 1 Newton times 1 meter, right? 1 times 1. 1 Newton. 1 kilogram equals about 9.8, almost 10 Newton. So 2 pounds is about 10 Newton. So 1 pound is about 5. Right? So here is an example says 1 Newton is about 1 apple. 1 pound is 5 apples, something like this, right? So maybe like this large. So 1 Newton is about the mass of 1 apple. Right? And 1 meter is from here to here. This looks like 1 meter, right? 1 meter is like a little bit more than 1 yard. So if you move 1 apple from here all the way up to 1 meter height, then that work needs to be done to the apple is 1 joule. Questions on that? That is very easy to memorize, right? 1 apple, 1 meter is 1 joule. Like this, right? Try again. See? That's easy, huh? Okay, the symbol for energy is, okay, you need to do the work of 1 joule to the apple. Then you need to have this 1 joule of energy. So work and energy is kind of related. The energy is the ability to do the work. If you want to do the work, you need to have the energy. The energy is used to do the work. So energy and work are related, so they use the same unit. The energy, the symbol for energy is W. And the unit for energy is, don't be confused with all these numbers. I know there's a lot of symbols.
Watts?
What?
No. Yes, no.
There's not watt.
So the symbol for energy is W. What is the unit for the energy? Joules. The unit for the work is joules. They are the same. So this is the label and the symbol for the energy, and the joules is the unit for the energy. This one, look, this one is like a little bit different than this one. What is this? This is this represents a watt, which is the unit for power. What is the symbol for power? We haven't discussed yet. Anyone knows? P, right? Power for P. Right? E for energy, but I don't know why this use W. W usually for work. Energy usually says use E, capital E. So it's same thing. So we just use W for the energy. But they usually prefer to use E. Okay, any questions? You need to memorize all these confusing or not confusing symbols. Voltage, symbol for voltage, unit for voltage, current, and charges, and the resistance, conductance. For example, what is the symbol for conductance? G, right? G. What's the unit for conductance? Sim. Yes. Okay. Good. Read the lecture. Read the textbook more. This one will be in the test, and you need to know that. And whether if you work for electrical engineering, then you need to know all these things. Energy is closely related to work. Energy is the ability to do work as such is measured in the same unit as work. So namely Newton meter or joules. Here, what amount of energy is converted into heat if we in sliding a box along the floor for 5 meters, which is the distance, if the force is 400 Newton. So move the box, right? The box we already said. The force is 400 Newton, and the distance equals 5 meters. Because the box is a uniform distance, so we assume there's no kinetic energy involved. So all the work be done will be converted into the heat. That means the box. There's friction between the box and the ground, so everything changing, the work changing into heat. So that's why it's not very clear for this one. So I'll explain a little bit.
400 times 5, 2,000.
So the result will be equals 400 times 5. So which equals 2,000 what? Joules or Newton meter. So we prefer use joules. So the result will be equals 2,000 joules. In our practice, in the homework unit or anything, you don't need to write this N. You don't need to write this L. As long as you use a standard unit. So if you can just use 400 times 5. But you need to make sure you use this N, not others. This meter must be meter. If you use meters, you don't need to write the unit. If you use other things, centimeter, you need to write the centimeter. Or you can just use it times 10 to the negative 2. 1 meter equals 100 centimeters. If you don't use it all standard unit, that's why I suggest you to use, because it makes things much easier. Because sometimes this formula is very long, then you are going to have a lot of numbers. You don't like to put all these units here. It's confusing. So you just use all the numbers, but keep in mind, the unit must be international standard. Then at the last step, you just put the standard unit for this guy, which is joules. You just put joule here, that's all. Very simple. Right? Power. So what is power? Right? The power is the rate of doing work. Right? That means the work per unit time, how fast or how slow you do the work. Right? Because it is a rate, means change of time, right? A time unit is required. Right? So the unit is joule per second. That means how much work you can do in each second. So which define the watt. The watt is equal to joule per second. What is joule? Joule equals Newton times meter. Right? So in this way, the watt will be equals Newton times meter divided by second. Right? That's the same thing here. Right? So the formula for the power is P, good, equals the work or the energy divided by the time. Questions on that? Now we have one example. What power is needed in the box example? If we move in 10 seconds, move the box, we said 400 Newton, right? The distance equals 5 meters. We didn't specify the time at the previous example. Now we said the time need to do this is 10 seconds, uniform, right? So what is the power? The power equals the work divided by the time. The work, we already know that, right? 400 times 5 equals 2,000. Then 2,000 divided by 10 equals 200. 200 what? Joules per second or watt. We prefer use watt. So the P equals 200 watt. When you do the calculation, you submit homework or test, except if it's multiple choice, you choose ABCD, then forget it. If you need to do the for response kind of questions, you need to give me the formula, plug into numbers, and write your solution with a proper unit. That is a very good practice. You need to write with this. So the power is defined by the work, the energy divided by time. So let me know you know the formula how to do this. Then you plug into the numbers. Okay, that is 2,000. This is equals 10. Then you calculate the result correctly and with a correct unit. The reason I request you write this one is, for example, if by some accident you think this one equals 200, by mistake you didn't see another zero, so 200 divided by 10, you said equals 20. If you give me only the number 20, what do you expect from me? Zero, right? But if you give me this, you write this one 200 here, divide by 10 equals 20. I see you are good here, you are good here. Oh, you are careless about this number, so that is a small mistake. So I give you like a 7 out of 10 at least. Does it make sense? So you know how to do it, but you just get the wrong number. So that is not big deal, or not as big as you just give me a 20. I don't know how you get this 20. Make sense? Yes. So my suggestion, this class, all the classes, right? You need to write step by step, so you can do the work. Even there's mistake, I can see where you are. You have the mistake, so I can give you partial credit. But in the multiple choice, you don't have this advantage. You choose 20, and that is wrong. Another unit for energy is kilowatt hour. Watt is the unit for what?
Power.
For power. Okay, kilowatt you just multiply by 1,000, so that's still a unit for power. And multiply by H. H here represents hour, which equals 3,600 seconds. So this is time. So this is power times time. So it must be a unit for energy, right? So kilowatt hour is a unit for energy. And this one is much larger than joules, because joules equals watt. This one is equal kilowatt, so that's 1,000 times here. And this one must be second. And this one here is 3,600 seconds. So this kilowatt hour is 3.6 million times larger than a joule. Make sense?
Yes.
One is 1,000 here. This one is 3.6 thousand, so that's 3.6 million times. The joule is very small, right? Move one apple to 1 meter. So kilowatt hour is much larger than this. So 1 kilowatt hour equals 3.6 times 10 to the 6, which is million joules. When we discuss utilities or other things, there's a lot of applications, we prefer use this one, kilowatt hour. The reason is because this joule is too small. You're going to have very small unit, you're going to have very long number. So we don't like that, we use a kilowatt. For example, this one, electric heater at home, and also your electric bill each month. They are going to say, okay, you use how many kilowatt hour. They do not use how many joules you use. That will be a bunch of like a long series of zeros. You know how much energy you use each month? No? A lot, yeah. How much? Give me an example, approximate. 400? How many kilowatt hour? 1,000? Okay, a typical is like close to 1,000. So each kilowatt hour costs like 13 cents. So you need to pay like $130, $150 each month. A typical family in US. So this is large. Right? Now we use this one to calculate something. This heater is rated at 1200 watt. What is this? This is the power, right? That's the power. And you operate this on this for 20 minutes. How much energy do you use? That's 1,200 watts. And you operate this for 20 minutes. How much energy? This is the power. This is the time. So power times time equals the energy. I can guess you are going to have two methods to calculate this. You want to use this one, 1200 times this one, you need to convert into second, right? So that one will be equals 1200 second. So use this one times this. Okay, you give me the result with the unit for joules. Oh, you can see this one is 1440000. A lot of zeros. We don't like that. Right? So instead, we are going to use a kilowatt hour. Kilowatt. This one equals 1.2 kilowatt. This one is hour. We are given minutes. So this one equals 1/3 of an hour, right? So 1.2 times 1/3, which gives us 0.4 kilowatt hour. Does it make sense? 1.2 times times 1/3 times 20/60. So the result equals 0.4 kilowatt hour. Like 5 cents. So you operate this for 20 minutes, you need to pay 5 cents. Any question on this?
No, sir.
Good, right? Okay. we discussed the power in general, mechanical power or electrical power in the general sense. Now, we are given a circuit. We know voltage, we know current, we know resistance, all these three parameters. We are going to find the power or the energy in the circuit. So, if we know the current, we know the resistance, the electric power will be given like this. P equals current squared times resistance. So that is the power. Actually, the fundamental formula is this one. The power equals voltage times current. So this is the fundamental one. We can derive this from here. We can derive this from here. So this one is the first one. P equals voltage times current. How to get this one? From Ohm's law, what is voltage? Voltage equals I times R, right? So this one, voltage equals I times R. So you plug, you replace this V with I times R. Then that one will be R squared over R, times R. And if we replace this current with what is the current in Ohm's law? Current equals V over R. When we replace this I with V over R, then we have another V here, so that's V squared over R. So you only need to memorize this one. So power equals voltage times current. And also the Ohm's law. The Ohm's law is the Ohm equals voltage divided by current. So when power equals voltage times current, resistance equals voltage divided by current. These two formulas are found. And you can derive all others from these two. Give you a second to think about this. Any questions? Any comments? Everything's good, right? Yes.
What is square come from?
Square, okay, so look this. This voltage equals the current times R, right? From Ohm's law, look at this. Right? See? It's Ohm's law. The voltage equals the current times resistance. And this one used to replace used to replace this V. So V equals I times R. So now I times R, then times another I. So that's why we get 2I. So I squared. Okay, any other questions? Yes.
So how do you know when you use a big one?
How do you know which one you want to use?
Either one of those. How do you, well, not P equals VI, but how do you know when you use the one with the square?
Okay, that's good. That means we have three formulas. Which one to use? If I give you a circuit, which one is to use? Look at this. If you know the voltage and the current, then you use this one. Right? If you know the current and the resistance, you use this one. If you know the voltage and the resistance, you use this one. These three formulas are called Ohm's Law. Right? So, what is the first law we discussed? Ohm's Law. And this is the second. Ohm's Law is more fundamental or more important than this one. Okay, here. Example, what power is dissipated in a 27 ohm resistor if the current is 0.135 amperes? Right? If you have a calculator, then you calculate. If you don't, then tell me how to do this. We know R, right? We know resistance. We know current. So the P equals the formula you mentioned, right? Current squared times R. Right? So that will be equals 0.135 squared times 27. And both unit here is good, this one is good, so we don't need to change anything. You just 0.135 squared times 27 equals what? Equals 0.49. What's the unit? Watt. W, right? Okay, you put the W with the parentheses at the very end. Alright, so this one, again, for the format, right? I don't want you to write this A. I don't want you to write this ohm because you already, both are already standard. But this one is good. I want you to put like a parenthesis or just leave like this. That's fine.
Okay.
It's good?
Yeah.
Okay, so that's 0.49. Yes, perfect. What power is dissipated by a heater that draws 12 ampere of current from a 120 volt of source? What do we know here?
E equals V.
We know
Current.
current I. What is this? Voltage. We know V and I. So which one do you want to use? P equals V times I. The one in the middle. Right? So 120, that's already good. This one, already good. So the result will be equals 1440. 1440, what unit? Watt. Right? Keep in mind, you need to put the unit. Right? Because if the unit is wrong, then your number is wrong. Right? Watt, you can use a kilowatt, which equals 1.44 kilowatt. So if the result give me 1.44, that's also correct, but the unit must be a kilowatt. Make sense?
Yes.
So don't only give me the numbers. Numbers means not everything. In engineering, we need unit. So you can give me 1440 with a W, or you can give me a 1.44 with a K. The most direct solution is to substitute into this one. The voltage times current equals 1440. Right? What power is dissipated in a 100 ohm resistor with 5 volt across it? What do we know here? What's this? Resistance. What is this? Voltage. So we know V, we know R. R. What formula should we use? P equals V squared over R. Perfect. V squared equals 25 over 100. Right? That is 25%. So 0.25. So it's a quarter, right?
Correct.
A quarter what?
Yes.
A quarter unit. Don't forget unit. Watt. Right? 0.25 watt. Right? It's very easy, right? So you can take your midterm right now. Okay?
It's like I need to study some.
Okay, so you should have 2 times.
Study some
So
more.
not that difficult. Right? That's pretty simple. Right? It is useful to keep in mind that small resistors operating at a low voltage system need to be sized for the anticipated power. What does that mean? This, see, the voltage is very small, right? 5 volt. 5 volt means just like the battery, right? It's very small. The USB voltage equals 5. It's very small. And this one here, the resistance equals 100 ohms, not that big. Usually it's something K ohm. This one is 0.1 K, so it's also very small. But the power, 0.25 watt, that is not that small compared to others. So if we are not careful, we apply this 5 volts to this small resistor. If you touch the resistor, you may feel very, very hot. Right? So sometimes it may be too hot that it burns your resistor. The resistor is gone, totally died. Right? So that says, to keep in mind that small resistors operate at low voltage system need to be sized for the anticipated power. Right? You do not want the volume, right? The physical size of the resistors very, very big. Right? Because look at your phone. Inside there are millions devices, small things. You do not want that big one. You want it as small as possible. But if it's too small, this kind of power can destroy your resistor in this case.
Is that why those phones a while back kept
Sometimes.
it was on the news, like, it had something to do with the batteries and the phones were like,
Oh,
Catching on fire.
it's the Samsung Galaxy phone blew up.
Oh, that's an immediate battery explode, right?
is it the same kind of thing there? Is that
Not exactly. That means the current is too large that the battery is too hot. Then it's exploded. This one means you destroy your resistor.
Okay.
This is something like the light bulb here, right? It's working. Then after some years, the wire inside just burn out, so you do not have power. That won't explode. So it's safe, but you don't have anything. So if the resistor is burned out, you are going to have an open circuit. That means there's no current, there's no anything at all. It's dead, but not explode. Still safe. But if you have a short circuit, you connect the positive and negative source directly. That is very hot. It's not dead, it's very active, it's very hot. Then maybe give you that. That thing is sometimes good, right? Any question on this? Right? So the key we learned from here is when you design a circuit, you need to use all the tricks we learned here to calculate the potential, right? The power will be dissipated on the device. Right? For example, if this one is very big, then you need to choose the physical size that is appropriate for this one. Otherwise, you're going to be in trouble. Right? If this one equals a milliwatt, then you don't need to care too much. 0.25 milliwatt, that is too small. So you just put the resistor, that's fine. As small as possible, that's okay. Does it make sense? Okay, like this. Right? If we are not careful, this is a normal resistor. Right? Look, all these color bands are very colorful, right? Red is red, blue is blue. But if it's too hot, be careful, don't touch. For example, if you want to repair something, for example, the TV or something, you open it, you do not touch with your bare hand randomly. Right? You need to know what you are doing. If you touch something really very hot, burn your fingers. So this one, look, it's very hot, and all the colors are burned. So this color is green is not green anymore. Sometimes even worse, you cannot see the color anymore. It's totally dark. So we know this is bad, right?
Yeah.
But we can use this. Right? For example, something is wrong, you open it, what you look? Right? You look for something that's weird, like this one. It's totally black, okay? So the color is not that beautiful. So you think, okay, this one may be wrong, maybe burned out. So this is the troubleshooting. The next one is expected battery life. Right? anyone of you has purchased a car battery? You go to the store, you buy the battery, right? So what do you look? First on price, then brand or something. That's okay. Ampere hour, right? So that's number. If you have a big car, big truck or something, you need that one. Number is big. So like 150 or something, 100 at least.
They usually say like cold cranking amps.
Oh yeah, that is another story. Okay, we are going to discuss it. But the first one number is like 150. That's called ampere hour. It's called this one. The ampere hour rating of this one. Big batteries, small batteries. Like if you have a battery that's small, then maybe just several. Right? If the battery is big, then maybe it's more than 100. So that is this. Right? So the expected battery life for batteries is given as amperes hour. For example, if the battery is rated as 100 ampere hour, it's fresh, right? Brand new. So it's exactly 100 A ampere. H means hour, right? 100 AH. If you draw a current of, for example, 2 ampere, how long can you use the battery?
50 hours.
50 hours. Right? So 100 AH divided by 2A give you 50 AH. 50 hours. So you can use that battery for 50 hours. If you use the current small one, you can use 100 hours. So that is the capacity. Usually we say capacity. Why is called the battery life? Life is capacity. So that is called a big battery can hold more energy. So you can use this one. But once you buy this one, this 100 AH, can you really get 100 A times H? Not necessary. That one, that capacity depends on a lot of factors. So for example, the rate of current. For example, if you use a small current, use 1 ampere, you can get 100 hours, right? Suppose. But if you use 10 amperes, most probably, theoretically, you can get 10 hours. But most probably you cannot. You may get only like 9 hours. Right? If you use, as you said, large current, it's like 270 amperes for cold or current. Right? Then, for example, use 100, you won't get 1 hour. So that's why I said the capacity depends on a lot of factors. The rate of current, withdrawal, the age of the battery, fresh, it's 100, and old ones, it's rated as 100, but like 5 years later, maybe only 60. 7 years later, supposed to be 0, supposed to be through and recycled, right? So that's the life. And temperature. What do you think how temperature can affect this? If the temperature is cold, it has more or?
Probably less. Slows down the chemical reaction.
I'm not quite sure, but if anyone has experience.
Pretty sure cold.
Resistance.
Yeah.
Okay, so I believe maybe in the textbook or you can check online later time. So there are some battery expert will explain it. Right? So I'm not quite sure, I cannot tell you this. But anyway, the temperature will affect this. Okay, here is an example. How many hours can you expect to have a battery deliver 0.5 ampere if it is rated at 10? Hurry up.
20.
20, perfect. Right? How we get that? Time?
Divide.
Divide. Okay. Which one divide what?
10 divided
10 divided by 0.5. Okay, so equals 10. Perfect. Good. That is the ideal case, right? So as we said, if you use a file here, you won't expect it to. So that's changed a lot. This is only theoretical. So 20 hours. Some questions to ask before we start any troubleshooting. We want to troubleshoot something. That is the ability for engineers, for electrical engineers. If you All of you want to be electrical engineer, right? No? You want to perform dance or something? Okay. So anyway, even you are at home, right? Your light bulb needs to change. You do by yourself, right?
Yeah.
Yeah. Okay. So for example, others there's no power. What do? You troubleshoot. So that's the fundamental skills. We want to know how to do this. So some questions to ask before start any troubleshooting. For example, your TV, and you watch the games, oh, boom, your TV is gone. You hire me to do this, that's like $100. Only to take a look. So you need to do by yourself. Has the circuit ever worked? Yes, I just watched TV like 1 minute ago. So that is good. If the circuit once worked, and what condition it feel? A sudden thunderstorm, then my TV is dead. So what do you think will happen?
Struck by light.
Yeah, struck by light. So which part may be
Either the breaker, your circuit protector.
okay, the breaker is easy to think, right? You check the breaker, okay, that's good. Then what else? Breaker is good.
Circuit protector.
Okay, that is also good. So your TV is wrong. So which part do you think the TV will be?
The wire.
The wire.
The fuse, actually.
The fuse, okay, that's the first thing, the fuse, like breaker outside, but fuse is inside.
Yeah.
Alright, that is why you check this one easy, alright? The fuse is good.
I don't know after that.
Alright, maybe some, so we need to have some technique to do this, right? We may guess maybe the resistor was destroyed, most probably the capacitor destroyed, and most probably the capacitor was destroyed. But which one? There are a lot of capacitors inside. But don't worry, right now there's only 2 boards inside your TV, the big TV. One is for the battery, another one is for all the CPU controls everything. So what you do is throw away this, change this one. Work, okay, you are happy. If not, then change another. That's the only thing you can do. 2 boards. But before we have a discrete, we have an integrated, we have the big TV inside. You can see the resistors or the capacitor, everything is transformers, transistors. Then you need to find out which one. There are a lot. So we have some tricks to do this. Also, you need to think what are the symptoms of the failure. Did you smell something? Oh yeah, something burned. Okay, so you know that. Or did you see a light inside your TV? That's possible, right?
Yeah.
So inside, then you see a light, spark. Then your TV is gone. Okay, so you need to consider all these phenomena, then decide which part is wrong. What are the possible causes of failure? We just guess, right? So all this, maybe a resistor, maybe a capacitor, maybe fuse, maybe breaker, circuit breaker, or everything. So that's possible. So you need to plan the troubleshooting by receiving pertinent information. Schematics. Schematic means like the manual, but that is the schematic is for the circuit. You need to know where are the transformers, where are this, all this, where are the capacitors, resistors. So you need to check this. Good news is usually we have online. All these manuals are online. Instruction manual. And the next one is you review when and how the failure occurred. Okay, the next one. Once we decided that inside the board there's something wrong, we need to use this. It's called half splitting. But I prefer use a divide and conquer. So how to do that? You split this thing in half. Determine if this one is wrong or not. This one. Then you split the half again. Anyone knows this trick? This trick is very useful in computer science. It's called divide and conquer. The rule is like this. For example, we have 20 suppose we have 32 students here, right? So everyone gets a number, 1, 2, 3, 4, like all the way to 32. So now I randomly draw a number. I want to guess what number is this. I can only ask, for example, okay, if this number is 18, so no, right? So this is one question. If this number is 10, no, okay, so this is the second question. I can only ask 5 questions. I will determine which one is this. So how to do this? Right? This famous example for divide and conquer. What we do is you split in half in the middle. 32 is 16, right? The first question I ask, is this number smaller than 16? And it says yes. Okay, then I forget this 17 to 32. I will work on this, conquer this from 1 to 16. Okay, the second time I will ask, 16 divided into 2 is 8, right? So is this number less than 8 or less than or equal to 8? It says no. Okay, so now I know it must be from 9 to 16. Then for this part, I divide again. Okay. Then finally I will get this one. So you use only 5 times to guess which one from this 1 to 32. Right? So this is very efficient way. You do not want to start from 1. Is this 1? No. Is this 2? No. Is this 3? No. Then you are going to, for example, if you have 1024 numbers, you want to guess, use this divide and conquer, you need only 10 times. Instead of go linearly from beginning to end, you need possibly need 1023, right? Because the last one you don't need to guess. Okay, so 1023. But you need to guarantee get the correct answer only within 10 times. Right. So this is the same thing. This same idea applied to this one. You have the board here, okay? So you disconnect or no matter what, you decide if the problem is on the first half or in the second half. When we talk like this, it looks easy, but how do you decide that? You need a lot of experience. Right? But anyway, suppose we know the problem is in the first one, and you forget the second half, you only work on the first one. Then you find somewhere that you can split, not necessarily right in the middle, but maybe, okay, this part is for the electric power, for the power, this part is for the control the gain or something, AGC or no matter what, right? You divide this one block by block, then you decide. So this is called half splitting. Any questions? This troubleshooting method works for electrical engineering. You do not work on this, you work for civil, mechanical, everything. This idea still works, right? Based on the plan for attack, look over the circuit carefully and make measurement as needed to localize the problem. How to measure the circuit? That is what we are going to learn in the labs. So you need to learn how to use the multimeter to measure the voltage, the current, the resistance, possibly the capacitance, inductance, and later time for higher level, you are going to use a more advanced equipment, for example, oscilloscope, to look at exactly what the waveform look like. For example, like this, or square wave, or like triangles. So all these are used for in troubleshooting. You are going to learn a lot of things here. It's very useful. And when you get out of the USM, you are going to get a job pay you a lot. Modify the plan if necessary as you proceed. That's for sure. After solving the problem, it is useful to ask, how can I prevent this failure in the future? For example, if you find that a resistor is burned, so next time you know this thing can be done. Usually, I repaired my fridge. There's a capacitor destroyed. If I replace it next time, maybe still again. That means the design is not good. That the capacitor maybe need to make it bigger or what. Anyway, that is the problem. So when you troubleshoot something, you'd better ask The owner, okay, is this wrong before? He said, yes, you replace this one, most probably this one. Not guarantee, but you need to check. Okay, Ohm's law. What is Ohm's law? What is Ohm's law? Ohm, the resistance equals Ohm's law. Ohm equals what? R equals voltage over current. You can predict this, get the other two, but a law stating the current is directly proportional to the voltage and inversely proportional to the resistance. So current equals voltage divided by R. What is the linear? Linear, we see the curve, right? The VI curve or IV curve. The linear means the relationship is a straight line. The larger that thing is a proportional increase or proportional decrease. That's the linear. Energy. What is energy? Energy is the ability to do the work, right? What is the power?
Work per unit time.
The power is the rate, how fast you do the power, you do the work, right? So it is the energy per time, per unit time. So energy is the ability to do the work, the unit is joules, and the power is the rate of energy usage, right? The energy per unit time. What is joule? The unit of energy or power? Energy. What's the unit of power? Watt. Okay, perfect. The watt is already good. Kilowatt hour. What unit is this?
How many thousands of watts per hour?
How many kilowatts per hour? No, that dash means multiply. Kilowatt times time.
Times 1,000.
Yeah, not per. Per means a slash, right? It's not kilowatt per hour. It is kilowatt times hour. Okay, that's a very good question. So make this clear. Right? This one is kilowatt times hour. Kilowatt is the power, right? The power times time is power times time. Is the energy? No? What is power? Power equals energy divided by time. Right? So power times time equals energy, right? So this one is energy.
Okay.
This thing is the electric bill you need to pay. Right? So that is the energy, not the power. You do not pay the power directly. Right? You can have a very large appliance, use a lot of power in some unit time, but you don't use it. Right? So that's fine. You can use a small power, but you use it for a very long time, you still need to pay a lot of energy. So this is energy. Ampere hour, this rating is for battery, right? Efficiency. What is the efficiency? Keep in mind, everything here is a summary, right? You need to read your textbook. Right? So summary. So what is the efficiency? Efficiency is we have a system here. You have an input, you have an output. The output divided by input, that ratio is called efficiency. For example, you have a AC. Right? The AC takes, for example, 100 unit of energy, but it only give you, for example, 90 unit of output, the cold air. So what's the efficiency for your AC system? 90 divided by 100, which equals 90%. The 90% is the 90 is the output, which is useful. The input is what you need. The 10, where are the other 10? Useless. It's wasted. Dissipated usually as heat, so even worse. So usually when you buy appliance, you want to use the high efficiency system. The higher the better. Okay? Okay, we are going to stop here. So it looks like we already almost finished this chapter. So next class we are going to do this quiz here and answer any questions to prepare you for the midterm. Okay, good. Thank you. Let me tell.
You still gonna send us the questions to the homework?
Oh yes.
Do we have to email you or you gonna just do it?
I do by myself.
All right.